Logarithm exponential equation. So logarithm function means we can use it as non-linear to the linear. So firstly we should use it as this is the exponential form. Exponential form means 2 power minus 3, 5 power minus 1, a square, a power 3, those are the exponential form. So exponential form, you get right in the logarithmic form. So how you put the logarithmic form? This is the equation log m base b is equal to n, then exponential form we can write n is equal to b power n. So that if you see that log n base b is equal to n, then you can write n is equal to b power n. So this is for the first one we use logarithmic form, and second one we use exponential form. Okay, so we do that example here. If you see that write the exponential form. So if you see the log 9 base 3 is equal to 2, so you can write the exponential form is equal to 9 is equal to 3 power 2. So this is for the exponential form. And also the second example, write the logarithmic form. So write the logarithmic form, so we write the things 5 squared is equal to 25. 5 squared 25, so you can write the logarithmic form. 2 is equal to log 25 and base 5. So this is the logarithmic and the exponential forms are changing. Okay, so we calculate. The formula is evaluate. Log 81 base 3 equal to 8. So without that, doing this and these are stable. So log now without. So this one is that we have to evaluate. Okay, firstly you have to find the exponential from the 81. So 81 can be divided by the 3. So we have to divide the 81 by 3. So 3, so first you got the 27. And you got the 9, now is 3. So that you how many 3 times 3 you have to multiply to get the 81. This is the 4 times. 3 multiply, 3 multiply, 3 multiply, 3 multiply, 3. So this is the 4 times you multiply. So you got it 3 power 4 is equal to 81. And therefore, instead of the 81, you can now substitute 3 power 4. So log 3 power 4 base 3. So in this case, you got the 4 log 3 and base 3. So log 3 base 3 means that if the log and the base are equal, you can assume that 1. For example, log A base A is equal to 1. And therefore, log 3 base 3 is 1, so you only got the 1. So this is 4. So by this way, you can find the exponential form. Okay, another one is evaluate. So we have to evaluate the log 1 third base 9. Okay, log 1 third base 9 you have to evaluate. So in this case, you have to convert it to the exponential form. So log 1 third base 9 is equal to 8. So 1 third is equal to 9 power 8. So 1 third means 3 power minus 1. 9 is 3 square power 8. So 3 power minus 1 is equal to 3 power 2 8. So that 2 8 is minus 1. So 8 is equal to minus half. So by this way we get find the chain and logarithmic and the exponential form. So that this one's firstly we write the thing. So we determine the log 2 of 5 base 5. So that log 2 of 5 base 5 is equal to 8. So that 2 of 5 is equal to 5 power 8. So then you can find that 5 power 1 third is equal to 5 power 8. Then 8 is equal to 1 third. A principle of logarithm. We use the logarithm to calculate the engineering application, especially that we use for the amplifier. Amplifier means that those are the electronic power supplying, those are amplifier. Amplifiers they include the electrical circuit. The electronic circuit input signal is a small, this signal is amplified to the surface level, so output signal will be bigger. So this is for the amplifier stage. So for the amplifier stage, we utilize the logarithm. So amplifier stage, we can find the gain. Gain means the output voltage divided by input voltage, output power divided by input power ratio is a gain. So the gain can be calculated by the logarithm. So according to logarithm, we can see the input. That means that we can measure the decibel unit. Decibel unit means the ratio of the power. So decibel unit. So ratio of power. And this one is the ratio expressed in bell. So ratio of power and the ratio that expressed in bell. So okay, 10 to 1 ratio this is a 1 bell or the 1 B. So 100 to 1 ratio is a 2 bell. So 2B. Okay, sir. 10,000 ratio 1 is a 3 bell. So this is 3B. And 10 power 4 ratio 1 is a 4 bell. So 4B. And 10 power 5 ratio 1 is equal to 5 bell. Or the 5B. So how to change the bell? Bell means the number of bells is equal to log 10 P2 by P1. So P1 means that input power. So P2 is the output power. So output power is greater than the input power. For example, if you input 1 watt, output power is 10 watts. So in this case, decibel ratio is 1 bell. If you input 1 watt and the output 100 watt, then we 2 bell. Input 1 watt, output 1000 watt, 3 bell. Input 1 watt, output is 10 power 4 watt, is 4 bell. Input 1 watt, output is 10 power 5, which is 5 bell. So this is for the bell unit. But in the starting measurement, bell is too small. So in this case, we have to utilize the decibel. Decibel means 1 deci is equal to 1 bell is equal to 10 decibel. 1 bell equal to 10 decibel. So 1 bell, instead of writing the 1 bell, you can write it 10 dB. Instead of writing the 2 bell, you can write the 2 dB. So 2 bell is in the right 20 dB. Instead of writing the 3 bell, you can write the 30 dB. Or also the 40 dB and also 50 dB. So this is for the bell and the decibel. So this is the decibel. Bell unit and the decibel unit can be converted. So we also modify the equation. So number of bell is equal to log 10 P2 by P1. And similarly, number of decibel is equal to 10 log 10 P2 by P1. So this is the number of decibel. 10 log 10 P2 by P1. So by the same you can calculate. So when you calculate the power, we use the decibel by this way. So input power and output power ratio, and then we take the log and then multiply with 10. And also you can also calculate for the input and output current ratio. So input current, input is a V of P1 I1, output is a V2 I2. In this case, you can also calculate the decibel. Similar formula, but the four steps are for the calculation where to use the 20 decibel. So for the power calculation, you got the 10 decibel, 10 dB. For the voltage, you can calculate dB is equal to 20 log P2 by P1. Also dB is equal to 20 log I2 by I1. So log base 10 P2 by P1 and log it then I2 by I1. By this way you can calculate for the decibel. So the next one is the amplifier. So input power is 0.0013 watts and the output is 6.5 watts. So also we have to calculate for the power gain. So power gain you have to calculate in the dB. So we use the formula. dB is equal to 10 log 10 P2 divided by P1. So this is the dB we can calculate by formula. 10 log 10 P2 divided by P1. So then we substitute here 10 log 10. So P2 is the output power is 6.5. Input power is 0.0013. Okay, so we substitute and calculate. So then we use the log 10. So 65 and 50013 you got. So this way we just 6.5. So 65000 and 13. So this 5,000. You got the 5,000. The 5,000 is this one we use 10 multiply 3.7. So this one will be the 37 dB. So you use the calculator and find the 5,000. So just you got the 3.7. So that will be the 37 dB. So this will be the power gain, the input power by output power. Output power by input power. And then log 10 log 10. Okay, this one will be the next one. The next one is we have to and the amplifier has an input power 1.7 milliwatt, output power is 5.8 watt. So we have to calculate the power gain. And also the attenuator has an input power 3.6 watt, output is 4.5 milliwatt. So find the attenuation. Gain means you see the first one, input is small, output is big. So this is the gain. And second one is the input is bigger, output is smaller. So smaller means the attenuation. Attenuation means the compromise. Reduce the power. Reduce the attenuation. Enlarging is the gain. Enlarging is the amplification. Reducing is the attenuation. So okay, so this one we have to first we calculate for the power gain. So power gain we calculate by equation. Power gain. Power gain is dB. So this is 10 log 10 P2 by P1. So this formula. 10 log 10 P2 by P1. You can calculate for the power gain. So then we use 10 log 10. Output of P2 is 5.8. Input power is 1.7. Millimeter is 10 power minus 3. So by solving this one we got the power gain. So then we use the power gain. Power gain you can calculate 10 log 10 P2 by P1. So 10 log 10 is 5.8 divided by 1.7 is 10 power minus 3. So you got a 35.3 dB. And second one also that you can calculate power attenuation. The unit will use the dB. So then we also that you can calculate 10 log 10 P2 by P1. Okay, so 10 log 10 means that this is a 10 log 10. P2, so P2 is at 4.5 milliwatt. 4.5 into 10 power minus 3. And P1 is at 3.6. Okay, so this is a 4.5 divided by 1000 divided by 3.6. You got this 1.25 into 10 power minus 3. So then you can find a log. So log 1.25 multiplied by 10. So 1.25 divided by 5 in this one you got the dB. Yes. That's the one. A minus log B. Okay, the next one is the three laws of the logarithm. So we have to apply the three laws. First law means that log A multiplied B is equal to log A plus log B. So this is the first law. Log A multiplied B is equal to log A plus log B. And second law. So this is the log A by B is equal to log A minus log B. And the third law. First law. So log A power n. So it's going to be n log A. So this is for the three laws of the logarithm. Okay, first problem is attenuation and amplification. So amplification means that A is the input power is 1/7 milliwatt, output is 5.8. So the bigger means the amplification. So we use the same formula, 10 log 10 d2/d1. The second one is that input 3/6, output is 4/5 milliwatt. So this is a smaller. Smaller means the attenuation. So 10 log 10 d2/d1 we calculate. But for the first answer we use positive, second answer we use negative. So if the negative the case, this means that attenuation. Output will be smaller than the input. Sometimes we need to compress the power. Sometimes you need to amplify. So in the case sometimes we use the attenuator, especially that we use the attenuator for the noise. If the noise is coming inside, we have to reduce the noise. So noise means the attenuator. Noise power need to be minimized. So this is why we use it. Sometimes we use the attenuator in the electronic circuit. Okay, this another one we use the loss of the logarithm. If you find the log A multiplied B, so just you can write the log A plus log B. And also the log A divided by B is equal to log A minus log B. Log A power n is equal to n log A. So those are the laws of the logarithm. Okay, we calculate the law of the logarithm. Evaluate. Log 36 base 3 plus minus 2 log 2 base 3. So we have to calculate. In this case, log 36 base 3 you can write. This is log 36 base 3. So this is a log 2 power 2 base 3. So this becomes a log 36 base 3 minus log 4 base 3. So if you see that n log A, you can write the log A power n. Similarly, if you see the log A power n, you can write the n log A. So that this one is a log 36 base 3, we don't touch this one. Second one is a 2 log 2 base 3. So this is the format of the n log A. So you can write the log A power n. So that becomes the log 2 square base 3. So 2 square is a 4. Okay, this is you got. After that, this one is a subtraction. Subtraction means that you have to utilize the second law. If you find the log A divided by B, you can write the log A minus log B. And similarly, if you find the log A minus log B, you can write the log A divided by B. So this becomes log A is 36 divided by 4 base 3. So this is a log 9 base 3. So log 9 base 3 means log 3 square base 3. So this is 2 log 3. 2 log 3 base 3, so you got it 2. So this is answer, final answer we get 2. Then this one is the chain of the base equation. So chain of the base means that, for example, you see the one log here, log n, base A. So you can write this one. This is a log n base B divided by log A base B. So this is for the chain of the log, chain of the base. You can change the base by the best formula. Because this is the first equation, is log A base 10 is equal to minus 2, you have to find the A. So in this case, you can write A is equal to 10 power minus 2. 10 power minus 2 is 1 by 100. So this is 0 by 0.1. So another example. Log 2, log 0.5b plus 0.2. Base is a 2. It's a minus 2. So to find a b. So this one is also you can write the same stuff. Log 0.5b plus 0.2 is equal to minus 2. So this is a 0.5b plus 0.2 is equal to 2 power minus 2. 2 power minus 2 is 1 by 2 square. 0.5b plus 0.2 is a 1 by 2 square. So 0.5b plus 0.2 is equal to, so this is a 1 by 4. So 0.25. 0.5b plus 0.2 is equal to 0.25. And then you can find it at b. So 0.5b is equal to, so this is a 0.05. So b is 0.05 divided by 0.5. So that will be as a 0.1. Equal to 0.1. Okay, another equation. So solve 2 power 8 plus 5 equal to 13. So 2 power 8 plus 5 equal to 13, so you can find 2 power 8 equal to 13 minus 5, so you got the 8. So 2 power 8 equal to 2 power 3. So just the 8 equal to 3. This is for the equation. And similarly, you can find log k divided by k minus 8 and the base 10 is equal to t. So find x. Okay, so this one we can solve here. K by k minus 8 is equal to 10 power t. So then we interchange k by 10 power t is equal to k minus 8. So 8 you got 8 can you decide 8 here. This is a k minus k divided by 10 power t. So this becomes that k is a constant coming out 1 minus 10 power t. So then you got the 8. So this is a k into 10 power t minus 1 divided by 10 power t. So this is the equation for the 8. So firstly, what is this with the 8? So 8. And second we use y equal to log 8 base 10. So you substitute a 0.2, 0.4, 0.6, 0.8, 1, 2, 3, 4, 5. So this one we can calculate. Okay, so you substitute here. So instead of 8, you see the 0.2 base 10, so you use a calculator. Then we use the answer, we use a minus 0.7. And this is a minus 0.4, minus 0.22. So, and then this one is a 0.8 is a minus 0.9. And minus 0.47 and 0.3 and this is a 0.48, 0.6, 0.7. So then we got. You got the data file, you can start plot the graph. The horizontal axis will be the 8 value. And vertical axis is a log 8. Log 8 base 10. So we start from letter 8, 0.2, 0.4, 0.6, 0.8, 1, 2, 3, 4, 5. We start. So this is a 0.2, 0.4, 0.6, 0.8, 1, 2, 3, 4, 5. And then we substitute here. So this is a minus 0.7. Start from the minus 0.7, minus 0.7, minus 0.4, minus 0.22. So minus 0.06, 0.096. And then start from the 0.3 and a 0.48. So this is a log A space then. And then it's 0.6 and 0.7. So this is a 0.2 is start from here to this point. So we can draw that graph. 0.2 here. And the 0.4 or 0.2 we start from this point. 0.2 is a start from 0.7. And then this one will be here. And 0.3 will be this one. 0.8 will be this one. And 1 will be 0. 2 will be the 0.3. 3 will be the 0.48, 4 will be the 0.6, and this one. So we call the graph like this. So this means that y equal to log A space and graph. Okay, the next one is a non-linear empirical equation. This means that some equation you can convert to the linear form. For example, this kind of equation, y is equal to AA squared plus BA. This is a non-linear equation. So y is equal to a squared ba. A is a power square. So square power means this is a non-linear equation. So we can change this one to the linear form. So how we change the linear form? To change the linear form. To change the linear form. To divide by 8. So that y is equal to a squared plus ba. So you have to divide by 8. So that will be the y by 8. So this is a squared by 8 plus ba by 8. So this is y by 8 is equal to a plus b. So we call like this. So y by 8 is a plus b. So this is we substitute. If y by 8 is equal to z, then z equal to a plus b. So this is the linear form. So z equal to a plus b. This is the linear form. Therefore, the equation will be the linear. So that will be this equation is this value the z. Also the value will be the 8. So this 8 is a starting point with the b. So go here, this slope equal to a. So that equation is z equal to a plus b equation. So this is the following value given here. A is 1, 2, 3, 4, 5. Y is 5, 6, 34, 57, 84. So if you use this one directly, the graph will be not linear. It will be because the graph. So to get the linear, you have to divide it and change the form. So the original equation is y is equal to a squared plus ba. So that we have to calculate z is equal to y by 8. So this means that a squared plus ba is divided by 8. So this will be the a plus b. So we got, so this becomes a linear. This one is we use as x is 1, 2, 3, 4, 5, y is 5, 16, 34, 57, 84. So first you have to use as z equal to y by 8. So we calculate 8, 1, 2, 3, 4, 5. So z equal to y by 8. Y by 8 means y is 5 by 1. It is equal to 5. And 16 by 2 is equal to 8. 34 by 3 equal to that. This is 11.3. 11 points are 1. And 4 by 3 is equal to 1.33. This is 57.4. So 14.2. And this is 84 by 5. So 16.8 like this. Then you can draw the graph. This is where is z. And this is where is the 8. 8 value is 1, 2, 3, 4, 5. Y value is where is z value is 5. And the 8. And 11 by 1. 14.2, and 16.8. So then we start from point like this. Then we call the graph. So that graph will be there. Y is equal to Z is equal to AX plus B. Graph. So that will be the graph. Logarithmic exponential equation. So logarithm function means we can use it as non-linear to the linear. So something we should use as this is the exponential form. Exponential form means 2 power minus 3, 5 power minus 1, a square, a power 3. Those are the exponential form. So exponential form you get right in the logarithmic form. So how you put the logarithmic form? This is the equation log m base b is equal to n. Then exponential form we can write n is equal to b power n. So that if you see that log n base b is equal to n, then you can write n is equal to b power n. So this is for the first one we use logarithmic form, and second one we use exponential form. Okay, so we do that example here. If you see this write the exponential form. So if you see the log 9 base 3 is equal to 2, so you can write the exponential form is equal to 9 is equal to 3 power 2. So this is for the exponential form. That's also the second example. Write the logarithmic form. So write the logarithmic form, so we write the things 5 squared is equal to 25. 5 squared 25, so you can write the logarithmic form. 2 is equal to log 25 and base 5. So this is the logarithmic and the exponential forms are changing. Okay, so we calculate. The formula is evaluate. Log 81 base 3 equal to 8. So without doing the any table. So log now without. So this one is we went to evaluate. Okay, firstly you have to find the exponential for the 81. So 81 can be divided by the 3. So we have to divide the 81 by 3. So 3, so first you got the 27. And you got the 9, another is 3. So that you how many 3 times 3 you have to multiply to get the 81. This is the 4 times. 3 multiply, 3 multiply, 3 multiply, 3 multiply 3. So this is the 4 times you multiply. So you got it 3 power 4 is equal to 81. And therefore, instead of the 81, you can now substitute 3 power 4. So log 3 power 4 base 3. So in this case, you got the 4 log 3 and base 3. So log 3 base 3 means that if the log and the base are equal, you can assume that 1. For example, log A base A is equal to 1. And therefore, log 3 base 3 is 1, so you only got the 1. So this is 4. So by this way, you can find the exponential form. Okay, another one is evaluate. So we have to evaluate the log 1 base 9. Okay, log 1 base 9 you have to evaluate. So in this case, you have to convert it to the exponential form. So log 1 base 9 is equal to 8. So 1 is equal to 9 power 8. So 1 means 3 power minus 1. 9 is 3 square power 8. So 3 power minus 1 is equal to 3 power 2 8. So that 2 8 is minus 1. So 8 is equal to minus half. So by this way we can find the change the logarithmic and the exponential form. So that this one's are firstly we write the thing, then we determine the log 2 of 5 base 5. So that log 2 of 5 base 5 is going to A, so that 2 of 5 is going to 5 over A. So then you can find that 5 over 1 that is going to 5 over A, then A is equal to 1 that. A principle of logarithm. We use the logarithm to calculate the engineering